Hey everyone, this is Martin doing a quick update video of Vector Out to let all of the 5 subscribers know that the prototype Vector Out is now available on itch.io. Download it for free, check it out, have a play. I'll show you the page just so you know, and I'll pop a link in the description as well. But there you go, Vector Out, a task breakout game. Just a little prototype, but you know, great to know what people think, any feedback, or if they enjoyed it, suggestions, things like that. I'm always open to that, of course. itch.io is a cool little place to do prototypes, and that's kind of what I've labelled this as in the settings. Got all these monster downloads. I mean, you know, 9 downloads. Wow. And a bunch of views. This spike was just because I shared it with a few friends the other day. And only 1 downloaded. Anyway, but yeah, there's the game. I'll put the link in the description. I'll show you what I did last. I can't remember exactly what I put in the video, in the last video on YouTube, but this was just ultra simple thrown together. I didn't want to spend time making a polished title screen or anything like that. Just something that got players up and running, and you know, it's a prototype. Seeing what people think. A couple of instructions, how to play, and the controls. I changed the art style a little bit, just to vary it up from the tutorial that this is kind of adapted from. And I added in a few example commands within the input text here. So if I go over there, you can see like it moves twice. Idea moving, just showing users how to do it. Click on space. Fast forward works as well. So there you go. I think, and I did put like an example kind of best time as well. So these are developer best times. These are actually in the game zip file as well. In fact, I didn't need to stop the game there. I could have just pasted it in. That's the whole point. Is you don't need to restart to reread that file. Anyway, but if I can just press F and it'll fast forward. It'll be 10 times speed, and I'll show this code in a second as I think it's pretty interesting. That's my best time, 75:45. It's just an example. I didn't really put like a ton of effort into that, to be honest. But anyway, this channel's a little bit more about coding, and I find that a lot more interesting anyway. So let's just take a very quick look at a section of code that I thought was pretty interesting, and this was very much pulled from like this gafferongames.com fix your time step. So there's the link. I'll put that in the description as well. But this is what made it not frame rate independent, but it made the physics completely deterministic. So that 75.45 was also the same on my other PC as well, and it should be the same for anybody else playing this. And I ran it multiple times because the idea is that you can replay inputs and it's exactly the same each time. And this is kind of like the magic that does that. And again, adapted from that article I just linked, that I showed you a link for there. But kind of briefly, and I'm skimming this because I've not looked at this in a few weeks, but the accumulator here is basically set to 0. And while the accumulator is greater than the fixed time step, which I've set to 60 frames per second, so 0.016, this will keep on simulating the loop of gameplay. So let's say that the accumulator here, like it adds the frame. So I'll step back a little bit. It adds the frame time. So let's say the frame time is 0.032, which is 30 frames a second. So what will happen here is the accumulator is indeed larger than the fixed time step, which we've set as 0.016. So what this will do is it will simulate it'll go through the input, check what has been processed, and then also the update, which is where the main simulation happens. It moves the ball, or the square I should say, checks for if the user has added any input commands like any of these, and then handles the collision and the resolution of the collision as well. Now, accumulator gets reduced by the fixed time step, which is 0.016. Now, continuing round to the while loop again, The accumulator is equal now to fixed time step, so it's going to run it one more time and do a simulation tick again. And now the second time it comes around, the accumulator is 0 and it's not greater than fixed time step, and that's where it continues on through, and the render happens there. So the cool thing is about this, and I thought it was really interesting, is that I didn't really understand the intricate details of fixed update and how that works. But for example, the same thing happens in Unity if the frame rate is very low, and I'll show you an example in a second. If the frame rate is super low, even, you still get the simulation being correct, and you don't get collision tunneling in this case. So it depends if you're using fixed update or not. But I don't know if I showed this before already, but the simulate slow frame rate, which I thought was pretty cool. Sorry, I always do that wrong. It's not declaration, it's definition. I do that every time. All I'm doing is just adding a random sleep of between 0 and 500 milliseconds, and that'll just sleep the main thread. And so that's a pretty chunky amount of time. I don't know if I just saved that then or not. Let's see. That's half a second. So that's an extremely low frame rate. But what you'll see is, in fact, it's so slow that it's not catching my inputs as I'm pressing them there. But you can see I'm not getting collision tunneling, and if I fast forward, I think this works as well. So the frame rate, you can see super duper low. The frame rate, well, I don't know if you can see it exactly on video, but it's extremely choppy. If I end it here, 75.45, exactly the same again. So that was an interesting read of this article, and just understanding how physics determination works and how you get it exactly deterministic. And this is really cool for debugging as well, I think, just being able to see if it still works correctly. The other thing that I was looking into as well, and I didn't do in this game, but was fixed point floating arithmetic. So very briefly touched on that. I didn't need to do that because what I had here just worked. But the idea is that, well, I was thinking, okay, what about floating point variance? Because if you do a float or a double, the last few digits of that and the fractional part can be different on CPUs. It can also be different from run to run. As far as I'm aware, it could be the same on different it could be the same on the same PC, but different on different architectures. I can't remember exactly, but the floating point the fixed point arithmetic fixed that by I think not using the floating point architecture of the CPU, but using the integer architecture and just representing floats through that. And so that's what made it. That's something I didn't have to dive into, but it's pretty interesting. So yeah, this one here, just our last point before I hop off. It's kind of late here, but this avoid spiral of death. You can read more about that in the article, but this was a good point as well that I sort of briefly understood. But it was the idea that if the frame time gets too large, you're constantly playing catch up with this, and it'll get larger and larger because the frame time will just get bigger and bigger and bigger. And then let's say the example before that I did, I ran this simulation twice. Okay, fine. But now the frame time has just increased from 0.032 to 0.064. Okay, so now I have to run this 4 times. And then because this took so long to run, this process loop, the next frame time, just to keep the numbers simple, is 0.128. Okay, well now I have to run this 8 times, and that's what the spiral of death is. It just gets bigger and bigger and bigger. So this is where you cap it, basically. So yeah, interesting stuff anyway. Any questions? Let me know what you think. I always think this is interesting. I'm going to do a probably next little tutorial I'm going to go through and do a devlog on is a platformer in C++ and OpenGL. So I'm looking at a tutorial right now. This whole thing is just so I can improve my C++ skills really and get down and dirty and get close to the metal, to the bits and the bytes. Because as a Unity developer, it's a lot is provided to you, and I think it's really interesting to understand what's going on under the hood more. And raw C++, with, I say, even without, and here I use GLFW, but the next one that I'm watching now is just going to be a straight use of Windows API, and OpenGL again. So yeah, you learn a lot. Anyway, check out the game, everyone, and I'll catch you in the next one.